Good day everyone! In this video, we will discuss about Introduction to Logarithm. What is logarithm? Let b, x, and y be positive real integers such that b is not equal to 1. The logarithm of y with base b is denoted by logarithm of y to the base b and is defined as x is equal to logarithm of y to the base b if and only if y is equal to b raised to x. With this definition, we need to remember the following. First, in both logarithmic and exponential forms, b is the base. In the exponential form, c is an exponent. This implies that the logarithm is actually an exponent. Thus, exponential and logarithmic functions are inverses. Second, when you were asked of what is the logarithm of, it is the same being asked what is the exponent of. Therefore, we need to study now the exponential and the logarithmic form. Remember, the exponential form is given by b raised to x is equal to y. And the logarithmic form is given by logarithm of y to the base b equals x. Having these two forms, notice that base would be written as subscript of the logarithm. The exponent x will be written on the other side of the equation, and the power y will be together with the logarithmic expression. Let us have some example. Rewrite each expression in logarithmic form. Number 1, 5 raised to 4 is equal to 625. And number 2, 1/2 cube equals 1/8. For the first given, 5 raised to 4 equals 625, notice that the base is 5, the exponent is 4, and the power is 625. With this, it follows that b is 5, x is 4, and y is 625. Remember that the logarithmic form is given as x equals logarithm of y to the base b. Hence, we need to substitute 4 to x, 5 to b, and 625 to y. It will now give us 4 equals logarithm of 625 to the base 5. On the second given, we have 1/2 as our base, 3 being the exponent, and 1/8 being the power. Then it implies that b is equal to 1/2, x is equal to 3, and y is equal to 1/8. Again, the logarithmic form is x equals logarithm of y to the base b. Thus, we need to substitute 3 to x, 1/2 to b, and 1/8 to y. It will result to the logarithmic form 3 equals logarithm of 1/8 to the base 1/2. Moreover, common logarithm is a logarithm with base 10. If a logarithmic expression has base 10, we usually do not write its base. Thus, if we have logarithm of x to the base 10, then it can be written as logarithm of x. Note that if you do not see any base in a logarithmic expression, it doesn't mean that the base is 0. It is automatically base is equal to 10 and the logarithmic expression is a common logarithm. Moreover, natural logarithm is a logarithm with base e. E is a natural number which is approximately equal to 2.71828. If a logarithmic expression has base e, we usually do not write its base, and we denote it by ln. Thus, if we have logarithm of x to the base e, then we can write it as ln of x. Let us have these examples. Rewrite each expression in exponential form. The first given is logarithm of 100 equals 2, and the second one is ln of e equals 1. For the first given, notice that since we do not have a base here, it means that this is a common logarithm with base 10. Meaning, b or our base is equal to 10. Also, we have x equals 2 and y equals 100. Recall that the exponential form is given by b raised to x is equal to y. Substituting b, x, and y to this exponential form, we will have 10 raised to 2 equals 100. On the second given, ln of e equals 1, notice that since we have ln here, it means that the given is a natural logarithm with base e. Therefore, it only follows that our base is equal to the natural number e. Going back to the given, we also have x equals 1 and y equals e. Therefore, if we will substitute b, x, and y to the exponential form b raised to x equals y, we will have e raised to 1 is equal to e. With the definition of the logarithm, we can now solve or evaluate simple logarithmic expressions. Let us consider these examples. For the first one, evaluate logarithm of 25 to the base 5 plus logarithm of 8 to the base 2. For the second one, logarithm of 1 over 64 to the base 1/2 minus logarithm of 27 to the base 3. For the first one, logarithm of 25 to the base 5 plus logarithm of 8 to the base 2. Looking at the first term, remember that when you were asked of what is the logarithm of, it is the same being asked what is the exponent of. Meaning, imagine that you were asked of what should be the exponent of 5 to have 25. With that, you may recall that 5 raised to 2 is actually equal to 25. Therefore, this would imply that logarithm of 25 to the base 5 is actually equal to 2. It means that for us to have 25, the base 5 should have an exponent of 2. On our second term, logarithm of 8 to the base 2, we were asked of what should be the exponent of 2 to become 8. Therefore, you may recall that 2 raised to 3 is equal to 8. Therefore, it only follows that logarithm of 8 to the base 2 is actually equal to 3. With this, the expression logarithm of 25 to the base 5 plus logarithm of 8 to the base 2 is actually equal to 2 plus 3. Simplifying 2 plus 3, we will have 5. Therefore, the expression logarithm of 25 to the base 5 plus logarithm of 8 to the base 2 is actually equal to 5. Moving to the next given, logarithm of 1 over 64 to the base 1/2 minus logarithm of 27 to the base 3. Again, for the first term, we were asked of what should be the exponent of 1/2 to be 1 over 64. So you may recall that 1/2 raised to 6 is equal to 1 over 64. Therefore, the logarithm of 1 over 64 to the base 1/2 is equal to 6. On the other hand, on the second term, logarithm of 27 to the base 3, we were asked of what should be the exponent of 3 to become 27. So you may recall that 3 raised to 3 is equal to 27. Thus, logarithm of 27 to the base 3 is equal to 3. With the values of 6 and 3, we can now equate the expression by 6 minus 3. Simplifying 6 minus 3, it will give us 3. Therefore, the expression logarithm of 1 over 64 to the base 1/2 minus logarithm of 27 to the base 3 is equal to 3. I hope that you have understood the lesson. For the next video, we will discuss about applications of logarithm. Thank you so much for listening and see you on our next discussion.